All right, in this video, I look at a few quadratic function things. Um, there's a couple of ways you can find a vertex given a formula, and we've got, I guess, two types of equations. We've got this type, the ax squared plus bx plus c, and then we've also got this type where it's just ax squared plus b. Oh no, sorry. We've got the other one that is f of x is equal to a x minus h squared plus k. So this is sort of the general format, and this one is the vertex format. Okay, but if I have an equation that is written in the general format and I need to find the vertex, there's two ways of doing that. I can either complete the square, which is hard, uh, difficult, or I can use a formula. And so if completing the square sort of isn't your thing, I guess I could show you both ways. And then I'll show you both ways and you can decide which. So if you want to take this form and convert it into this form, what you do is you take the first two terms and isolate them, okay, plus 14. And then you have to factor out whatever's in front of the x squared. And here there's no number in front of the x squared, so we assume it's a 1. So that I have to factor out a 1/2, okay? And then x squared plus. Now, if I factor a half out of 6, it'll be like, I'll do it down here, 6 divided by a half, which is the same as 6 times 2 over 1, or 12. So this would be 12x here, okay, plus 14. Now I complete the square. So the complete the square part will be where I take the 12x and divide it by 2 and then square it. So I take 12 divided by 2 and square it. 12 divided by 2 is 6, 6 squared is 36. So I need to put a plus 36 in there. And then outside here, I have to take whatever's in front and go negative 1/2 times by 36. So I can't just add a 36 in without compensating it somewhere, and that's what this is out here. Okay, now I'll factor this, and this will now be a perfect square. If I factor two things that multiply to 36 and add to 12, it's 6 and 6. So really I have x plus 6 squared. And then I have to figure out this other stuff over here. Half of 36 is 18, so it'd be minus 18. So it'd be a half times x plus 6 squared minus 4. Now you notice that in that there's lots of places where you can go wrong. Like this factoring out a half, a fraction out of something, that's a little tougher. The divide by 2 and square thing, and then making sure you don't mess up on that side, that's a little tough. At any rate, from this one, you do come up with a vertex of being a negative 6 and a negative 4. Now, it turns out there's another way you can do it, and that is using a formula that they show in the book. And they say the vertex is found by just going minus b over 2a, figure out what that is, and then once you find that, plug it into the function wherever there's an x. So do the f of x thing, but instead of the x, you plug in whatever you got from step 1. So let's do that. So to find the x value of the vertex, I just have to go minus b over 2a and minus, okay, b over 2 times a. So b, in this case, let's go back to this original one right there. That would be b is a 6 divided by 2 times a. And a would be this number that's in front of x squared, which is 1 over 2, or 1/2. So 1/2. Okay, so that'll be minus 6 divided by, is that right? Yeah. 2 times a half would be 1. And so the vertex would be minus 6. Not the vertex, the x value of the vertex. Notice that that's what I got up there. Now to find the y value of the vertex, as I said, as this says there, and it's sort of a funky looking thing, but it's basically saying if you have this function up there, let me write it out again. If I have f of x is equal to a half x squared plus 6x plus 14, then what I do is I plug in what I got from the first bit, the minus 6, everywhere there's an x. So I'm going to go f of minus 6 is 1/2 times something squared plus 6 times something plus 14. So that something is my minus 6, minus 6. So minus 6 squared is a positive 36. Half of 36 would be 18. 6 times minus 6 is minus 36. And so if you add that stuff up, 18 minus 36 is negative 30, or negative 18. Negative 18 plus 14, I think, is a negative 4. And that's what they got there. Which way do you like better? I typically like to do this way. On a test, I may ask you to do a complete the square one, but I typically won't give you one. I won't give you one where there's a fraction for A, and typically I don't give you one where there's an odd number for that one, because that makes it hard to factor too. Now, so using this method will help on lots of those questions at the end of this assignment, where they ask for a baseball or some other bicycling or whatever those things are. If they give you a formula or a function, x squared kind of function, then to find the vertex, all you have to do is plug it into this formula. So you don't have to fight through completing the square. Now, just as, why don't we answer some of the questions that they also asked here, because that might help a little bit. So the vertex we found two ways is negative 6 and negative 4. The axis of symmetry is always that first number, so x equals minus 6. Does f of x have a maximum or a minimum? Well, since a is positive, so since a is greater than 0, then the parabola goes like this. Therefore, it must have a minimum. So it's going to have a minimum. And the minimum value is whatever that value is. So the minimum value, it says type an integer or a fraction. It would just be negative 4. That's how low the thing it could go. And then they say, graph the thing. Okay, let me graph it over here on our graph. So the vertex, I know, let's use blue, is negative 6 and negative 4. So negative 6 there, negative 4 right about there. So that's the vertex, and I know it goes up, and so I'm just going to have a thing going up. One last thing to help me sort of figure out how skinny or fat this thing should be is this last number, when it's written in that form, is the y-intercept. So if I go up to about here, that's where it has to cross the y-axis. So when I make my parabola, I'm going to have it going up like that. And so the left side should look something similar to that. Okay, hopefully that helps you with that one. One other type of question, this one here, they say graph this one. This one is in the vertex form. So f of x equals a x minus h squared plus k. So whatever the h is, and you switch the sign, and whatever k is the vertex. So if I had like 2x minus 3 squared plus 4, my vertex would be a positive 3. Remember, switch this sign, and you don't switch that sign, it'd be a 4. Now, what happens if you don't have a number after there? Well, I guess we can assume that number is 0. So my vertex is going to be a positive 5 and 0. Remember, switch that sign, and 0. Okay, so 5 and 0. So that's not that one. It's not that one. Oh, could be this one. Could be that one. Because both those have a vertex that look to be at about 5, 0. Now, to tell whether things upside down or not, you look at the sign in front. So if that sign's negative, it must mean that graph is upside down. This graph would have been f of x is equal to a positive x minus 5 squared plus 0. That's what that graph would look like. But if it's negative, upside down, has to be C. All right, so these questions here, when they're asking what is the vertex of that, if it's not in the vertex format, you can complete the square, it's an option, or you can just use that formula, the minus b over 2a, and then what's the value of the function when you plug in what you got from step 1 into the everywhere there's an x. I'll just go through the formula again with you. So to get the x coordinate, it would be minus something over 2 times something. Okay, B is a positive 4, and A is a 2. So negative 4 over 2 times 2 is 4. So the x-coordinate of the vertex is going to be negative 1. Negative 1. And then the y-coordinate, I just find the value of the function when I plug in a negative 1. So it'll be 2 times something squared plus 4 times something minus 16. So the something is a negative 1. Negative 1 squared is positive 1 times 2 would be a 2. 4 times negative 1 is a negative 4 minus 16. So 2 take away 4 is negative 2 minus 16 would be minus 18. So that's the y-coordinate, minus 18, of the vertex. So if I wanted to graph it at negative 1 and negative 18 way down here, that's where the vertex would be. Since it's positive, it would go up like that. Oh, and that y-intercept right there is that number right there, minus 16. Okay, but that vertex is a negative 1, negative 18. All right, maybe one last thing about intervals. There's an interval here. It says, on what interval is the function decreasing or increasing? Interval, they're asking x values. So what's happening with y when x does something? So here I see the graph is falling to that point, and then it's rising or increasing to that point. So if I'm looking at x values, left and right stuff, so as I'm coming in from negative infinity, I go all the way to negative 1 for my x value, and during that interval, the graph is decreasing. And then from the interval from negative 1 all the way up to, I guess, positive infinity, the graph is going up. All right, hopefully that'll help you with those. Now these ones here, these last ones, I would use your minus b over 2a, that formula right up there to help you with those. Try it. If you have questions, give me a text.